Hey guys, Mr. Kyle, Myers Mathematics, and let's just jump right into it. So today I want to talk about the Envision 2020 Geometry Topic 1 Solutions. That's the title. It's the thing at the top. What I'm going to do is I'm just going to go through all the pages 64 through 67 in the new Envision books and just go through and just do the solutions and work out the problems to each one so you can see what the answer is and see how to work out the solution if you got stuck on one of them or if you need help on the homework or things like that. So without further ado, let's just go ahead and jump in here to the vocab review and get to number 2, which I'm not sure why there's a number 2. Actually, I think there's a number 1 on the previous page or something that I'm missing. I don't know. Oh, no, number 1 is at the very top when I cut it out because it was the essential question. What are the fundamental building blocks of geometry? Legos. That's the answer. Okay, so anyways, number 2, statement accepted without proof. A statement accepted without proof. So that's a postulate. All right, so you might have heard like, oh, you're just postulating. All right, so a statement accepted without proof is a postulate. Postulate. Right? Then we have arriving at a conclusion by observing patterns is, well, the key word there is patterns. If you're observing patterns, that's inductive reasoning. So I'm just going to call that IR, inductive reasoning. All right, a blank is the combination of a conditional and its converse. If you combine two statements, there are two. The prefix for two is by, so biconditional. Biconditional. Sorry, it's a little sloppy there. It doesn't really fit, which is why I like to abbreviate. All right, number 5. According to the blank, if a conditional statement and its hypothesis are true, then its conclusion is also true. So, for instance, if I said, if today is Monday, then tomorrow is Tuesday, right? So, if it is Monday, then tomorrow must be Tuesday. That's all they're saying, which is kind of dumb, but it's called the law of detachment. LOD, law of detachment. All right, sort of like a no-duh kind of law. Law of no-duh, or law of duh. There we go. A conjecture that has been proven. Okay, so you've proven something. Fancy. If you've proven something, a conjecture that has been proven is a theorem. Theorem. A statement of the form if not Q, then not P is a blank of the conditional if P, then Q. Okay, so when you say if P, then Q, that means you're saying like if blank, then blankety blank, right? So if you look, they switched the letters. If not blankety blank, then not blank. They switched the letters. If you switch the letters, that's the converse. But they also put nots in front of them, right? Like Borat, this suit is not black. Okay, if they put nots in front of the things, that's also the inverse. If you combine the inverse and the converse, you get the contrapositive. So, contrapositive. Contrapositive. All right, you use blank when you logically come to a valid conclusion based on given statements. Deductive reasoning. Deductive reasoning. And there we go. All right, so I'm going to move down to the next section here. And I'm going to zoom out just a little bit because I'm going to need to probably use the space below to solve 9, 10, 11, so on and so on. So this is still page 64. 64. They give you an example, but the example is maybe not as helpful if you're still stuck, or maybe they did something different than the example or something like that. So let's go ahead and look at it here. The best way to do this is to understand that if I add two things together, I get the whole thing, right? So if I add LM plus MN, then that equals 45, aka the whole thing. Oop, just glitched on me there. So if I add the two parts, I get the whole thing, which means 45, this is number 9, 45 equals, notice 45 equals, right, equals 3x plus 2 plus x plus 19. You just copy them all down word for word. And then math happens. So in order to do the math, we would do, let's go ahead and combine like terms. So 3x plus x, that's 4x. Right, 3x plus 1x, 3 plus 1. And then we have, so I'm going to cross that out so I don't forget to add something else on accident there. 2 plus 19, 21. The actual 21, not 10 plus 9. Equals 45, 45. And then we subtract 21 on both sides. Boom, boom. So 4x equals 5 minus 1 is 4. 4 minus 2 is 2. So then I get this guy. And one more step. Divide by 4. Divide by 4. 24 divided by 4 is 6. So x is equal to 6. Very, very cool. So we actually do the same thing for number 10. I'm going to kind of slide this over this way a little bit. All right, so number 10. Just squeeze this in over here. RS is 27. Find QS. Okay, so this is a little different. Let me go ahead and just erase 9. So if you didn't already get the solution to number 9, probably just going to be easier if I just do this. I'll just zoom out a little bit more here. So I'm going to go ahead and erase 9. Pause it if you need to. And I'll just do all the solutions right here, instead of scrolling around trying to find some new space, some new real estate. So number 10, RS is 27. This one you have to be careful because RS is not the whole thing. QS is the whole thing, and that's what we're trying to find. So RS is 27, but they also say that RS is 12x minus 21. All right? You have to be careful. That was a trick. All right? The whole thing is QS. That's what we're trying to find. RS is also, it's 27, which is also 12x minus 21, which means 27 equals 12x minus 21. And then we can solve by doing math. So add 21. Add 9 plus 10. 12x equals 7 plus 1 is 8. 2 plus 2 is 4. Big facts. And then I divide by 12. Divide by 12. Ba-doop. And then x equals 48 divided by 12. That is a solid 4. So x is 4. Are we done? No, because they want QS. They want the whole thing. Well, we know RS is 27. So we just need to figure out what QR is and then add that to that. All right, this is a little harder, but it still can be done. We just need to figure out what QR is. QR is 9x. Excuse me. QR is 9x, and we already know what x is now. So x is 4. 9 times 4 is 36. So this is 36. This is 27. If we just add those up, 36 plus 27, 6 plus 7. Right? So if you have trouble with that, it's 7 plus 3 is 10, and then 3 more is 13. 3 plus 2 is 5, plus 1 more is 6. And I get a big old 63 for the final answer for number 10. That's quite the doozy. All right, so number 10, the final answer is 63. All right, I'm going to go ahead and erase this, so pause it if you need to. Move on to numero unce. All right, and I have a feeling this video is going to be a little bit longer, so feel free to pause it at any time and skip forward or back to whatever number you need to go to. So number 11, find the measure of each angle. Oh, very cool. Well, they give you a little diagram here, actually. So we can actually just kind of look at this diagram and go off of that. Notice there's like some little tick marks in here. So one way to figure out what the angle is to go ahead and look at the first letter and the last letter of the named angle. And then what you'll find is that if you connect those, you basically get the space of the angle. All right, so give me a second. So for number 11, you have the measure of EBG, so that goes from E to B to G. So it's actually this whole space right here. All right, so the whole space, there's two angles. Right, so EBG, the whole thing, the whole space, that's 60. All right, cool. And then FBG, so let's get rid of that there. FBG, so that's this guy. So that's a piece of that angle, right? So it's a portion of it. And that is equal to 2 times the measure of EBF. Okay. Well, you know what? That's also in here because EBF is right here. EBF, that's that little guy. So we need to figure out what's what. Well, notice they didn't tell us like what anything was really. I mean, besides EBG, that's 60. But other than that, they were just saying like, oh, FBG is 2 times the measure EBF. That's a little confusing. So what we can do is, since they didn't really give us anything to solve for, I mean, we want to solve for EBF, but why don't we just call this X? We're going to solve for X. All right, so EBF, we're going to call that X. So 2X, the measure of FBG is 2X. So that means this right here is 2X. That's X. And so I just add them together, X plus 2X. There we go. All right, so X plus 2X, that's 1X plus 2X is 3X, equals 60, divide by 3, boom, X equals 20. 20 is la respuesta. So we have 20 for the answer. And are we done? Yes, we are done because they just wanted to know what X is. They wanted to know what EBF was, and that's what X is, which is 20. So we solved it. Done. Get rid of some of this here for the next problem. I didn't warn you that time that I was erasing it. Sorry. If you need to go back, you can. Because it's a video. So number 12. ABE. Where's that? All right, well, ABE, that's that whole thing. So again, excuse me, this is the whole thing. This is the whole angle. Also notice that there's little tick marks down here. I don't know if you noticed this. There's like a little tick mark right there and a little tick mark right there. That means that those little pieces are the same angle. They measure the same amount. When you put little tick things on it, they're called tick marks. But when you do that, it means that they're the same. So the little pieces are the same. Well, ABE, if that's 64, then each of the little pieces would have to be half that much. So 32. So from A to D, that's 32. And then from D to E, that's 32. 32 plus 32 is 64. Okay. And now we need to know what DBE is. Okay, I think I covered up D because I don't see it. There it is, DBE. Oh, well, that's 32. Boom, done. All right, so the answer to 12 is 32. All right, moving on. Number 13. All right, so for number 13, GBH is 28. GBH, that's right there. Okay, so GBH. Notice I'm connecting the ending letters. I mentioned this earlier, but I'll say it again. If you want to know what angle they're talking about, just connect the ending letters. I connect the G and the H, and that's the angle they're talking about. Right? They're talking about that little piece. So if that's 28, notice they have the little tick marks on here again. This time there's 2 tick marks on each one to differentiate from the other one that has 1 tick mark on each one. The sniffles this morning. So if you have 2 tick marks on each one, that just means that they're not the same as the other thing with 1 tick mark. It doesn't mean anything different to put a different amount of tick marks. All right, there's 2 little things on there, but it doesn't mean anything different. It just says, hey, the things with 2 are different from the things with 1. So that's all that is. But it does mean that GBH and HBC are the same angle. They are both 28. So if they are both 28, right, so GBH 28, and then HBC also 28, then GBC, right, so they want GBC, they want this guy, which is this, right? Connect G and C, that's the whole thing. So they want the whole thing, which is 28 and 28. 8 plus 8 is 16. 2 plus 2 is 4, plus 1 is 5. So the answer to that is 56. There we go. All right, moving on to number 14. So for number 14, point K is located at 7 on a number line, and JK equals KL. Okay, so notice they don't really give you a picture for this, but if they don't give you a picture, then why not just draw one, right? So point K is located at 7 on a number line, right? So number line, number 14. Okay, so here's K, and it's at 7. And JK equals KL. JK equals KL. So that means the distances are the same. So the distance from J to K is the same as from K to L. That's what that means. Okay, if the coordinate of L is 23, what is the coordinate of point J? Okay, well, all you need to do is figure out what the distance is, really, because we could figure out what KL is, but if you think about it, if I need to travel from L to K, I need to travel from 23 to 7. So how much am I traveling? Well, I'm traveling 23 minus 7. Oh, I put times, but I meant minus. 23 minus 7. So 7 from 3, I would have to go 3 and then 3 more. And then that would be a 1. So 16. So the distance is 16. So KL is 16. Well, if I travel another 16 distance, so I'm going to start at 7 and go 23 spaces, I would need to subtract. You might be thinking, oh, wait, why not do 23 minus 7? Wouldn't that make more sense? Well, kind of, but I need to travel another, I meant to put 16 here. I need to travel another 16 spaces. So the space from here to here is 16. I need to travel another 16 spaces. Dyslexia this morning. I need to travel another 16 spaces. So I need to go 16 spaces. You could also subtract them the other way around. 16 minus 7. The problem is I would get 9, and if you travel to the left on the number line, I'm at 7. If I travel more than 7 spaces, I'm going to get into the negatives. So you just need to remember, hey, I can do 16 minus 7, but I'm supposed to be on the negatives on the number line, because at some point, 0 is around here somewhere. And then you have to keep going to get to negative 9. So the answer is negative 9 for number 14. La respuesta. All right. So there we go. I feel a sneeze coming on. One more. No, that's it. Okay. Man, allergies are the worst. Don't get old, kids. It's terrible. All right, so let's see. Next page, page 65. So if you already skipped to this page, welcome. You are about to get to a place where I'm not going to do a whole lot, because you don't actually need to know how to do constructions. You just need to know how to identify them. Okay? So if you copy the segment, then let's just assume I've already copied it. Boom, 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 copied it. All right, cool. And then construct the perpendicular bisector. So in order to do that, you would need to kind of create a little circle. So it would be like this kind of, around the point S. So something like that. A little circle around the point S. And then another circle around the point T. And then what happens is you get these little places where the two circles intersect. So if I were to draw out the whole circle, right? So let me actually go back a little bit. Get rid of some of these. You know what? This would be easier if I erase. So if I were to just imagine like a circle, right? So circle there and a circle there. So notice they intersect twice. Well, when you identify constructions, you're not going to see the whole circle, though. You're only going to see where they cross. So you're only going to see this part right here. And then you're also going to see, obviously, the line that connects them, because that line is a perpendicular bisector. Da, da, da. So it would look kind of like this. You're going to see little tick marks like that, kind of like a curvy curvy X. And then you'll see a little, line that connects them. And you might see some tick marks over here too, to show that it splits the segment into two pieces. All right, but look for the curvy X, and then the line that connects it. Sort of like a palm tree reflected on the water. That's kind of what it looks like. All right, this little palm tree. All right, copy each angle and then construct its bisector. So in order to do the bisector, I need to first do a little circle around the point K. So something like that. All right, it's a pretty nice circle, if you don't mind me saying. All right, pretty amazing. It's amazing what I can do with just drawing it, right? I know it's terrible. It's okay. So little piece right there. Notice where the circle intersects other places. That's the important part. Then the next step is we would actually draw two little circles that go like this and like this. Kind of like you're going to do the perpendicular bisector all over again. Because look at that. Perpendicular bisector is really like your bread and butter. Okay? And then you'll see right here, you'll see this tick mark and that tick mark. And then you'll see it connect like that. So if you're looking for just the tick marks, here's what it looks like. You'll have a little tick mark out here and out here. And then you'll have little tick marks right here and right here. And then you'll have your angle bisector right like this. All right, so it'll look something like that. It'll be a palm tree with some little shady parts on the side there. All right, so that's what your angle bisector looks like. You don't need the other little X on the other side like we did for the perpendicular bisector because it would just intersect with the point L, so that's why you only see like one palm tree on that guy. All right, but that's what it's going to look like when you try to identify it. Number 19, make sense and persevere. Persevere, goodness gracious. All right, why must the compass width be larger than half the segment width to draw a perpendicular bisector? Why must the compass width larger than half the segment width to draw a perpendicular bisector? Probably because it wouldn't connect. So if the compass width is not larger than half the segment width, then it wouldn't connect. You wouldn't be able to connect the things to draw the perpendicular bisector to start with. So we could look at examples of that, but the answer is just it wouldn't connect, basically. Number 20, model with mathematics. The sides of a roof meet at a 120-degree angle. A strip of wood extends down from the vertex so that it bisects the angle. Draw a diagram of the roof with the bisecting strip of wood. Okay, so all they're saying here is just, to draw a house, basically. So if you remember back in the day when you used to draw houses for fun, right, you would draw it like this, and you got a little house. Remember that? All right, so what they're saying is, hey, this guy right here is 120 degrees. And they're going to do an angle bisector. So it's like, hey, there's a vertical support beam or whatever. Okay? So that you have two of the same angle on either side, and each one would be 60. And that's pretty much it for that. All right. And then you have this guy, lesson 1-3. So we've left lesson 1-2 already. It's really just identifying constructions, so not a huge deal. I'm going to zoom out a little bit because this is midpoint and distance. Oh, I did not mean to move that. Grr. Let's move that back. There we go. That's better. Okay. I'm just trying to move this down. Here we go. Okay. So if I want to do the midpoint, I use the midpoint formula. If I use the distance, I use the distance formula. You don't have to remember either one if you can remember that the midpoint formula basically works because you're finding the average. If I want to find the average of 2 points, it's going to be the point that's right in between them. This is really helpful if you have like a best friend and he or she lives like kind of far from you. What you can do is you can go on Google Maps and you can look up the coordinates of your house, the coordinates of their house, and then you do the midpoint. Obviously, I would use a calculator for this because the numbers are crazy. But you can look up the midpoint, and that would be the point that's exactly in between you guys. Fun little use of the midpoint formula there. But if I want to find the midpoint, I just take the average. You add up the two numbers. Since you're adding up two numbers, you divide by 2. If you were to add up three numbers, then you would divide by 3. Right? So that's all that is. It's just the average. And then distance formula is basically just Pythagorean theorem. So I'm actually going to use I'm going to use the midpoint formula, but just under the guise of the average. And then the distance formula, I'm actually not going to use. I'm just going to use Pythagorean theorem, right? Because I kind of prefer that. So first of all, 21, EF, we want to find the midpoint and the length. All right, so EF, that's from here to here, from here to here. All right, so E looks like it's at -3, 2. And 2. I'm just going to kind of write them out there. And then F looks like it's at 1, 3. So 1, 3. Add, divide by 2. Boom, boom. -3 plus 1 is -2. Over 2 is -1. 2 plus 3 is 5. 5 over 2 is 2.5. Or you could just count the spaces and then count half that many spaces. So if I want to go from E to F, I would count 4 spaces. There are 1, 2, 3, 4 spaces, and 1 space up. Okay, so if I count 4 spaces, well, half that many would be 2. So I'd go 2 spaces over from E, and that would be at -1, the x value of -1. Right? And then if I want to count the spaces for up, it only goes up 1 space. So half of that would be half. Half of 1 is half. So I would go up to 2 and then go up half as much to 2.5. So you can also do it that way if you want to just count the spaces and then count half that many. That works too. But the midpoint would be -1, 2.5. Then for the distance, you have to remember that it's basically Pythagorean theorem. So we want the distance, the exact distance, which is always the hypotenuse of a right triangle. So that means I want to find out what a squared plus b squared equals c squared is. C squared being the hypotenuse, being the distance. So A is 4, I already counted it. It's 4 spaces to the right from E to F. And then 1 space up. So boom. So 16 plus 1, that's 17. That equals C squared though, so I need the square root of 17. Square root of 17 is the distance. Okay, that's all we do for that one. Square root of 16. Or sorry, square root of 17. For the next one, erase this too, we have FG. So over here. So if I count the spaces, let's see. 1, 2, 3, 4 spaces. So in between would be 2 spaces. And then if I count up, I go up 2 spaces. So look right there, boom. This little space right here, this little dot, right there. There's the midpoint. And you can kind of just tell, right? It's 2 spaces away from F and G, left and right, and then it's 1 space away from F and G, up and down. So that's the midpoint. It's 3, 2. Right? So for 22, 3, 2. There's the midpoint. All right, for distance, it was a space of 4 to get from F to G, and a space of 2 to go down, a space of 4 to go right, space of 2 to go down, or up and left, or whatever. So 2 and 4, 2 squared plus 4 squared equals c squared. A squared plus b squared equals c squared. Pythagorean theorem. 2 squared is 4. 4 squared is 16. 4 plus 16 is 20. That equals c squared. Careful. Square root, square root. I don't know if they'll want you to take and simplify this radical or not. If you're in Geo Reg, probably not. But if you're in Geo Honors, probably. So let's go ahead and look at what that would look like. So the trick to simplifying a radical is basically just to think like, okay, what are all the factors of 20? And are there any factors of 20 that are square numbers, right? So square numbers are 1, 4, 9, 16, so on and so on. 20 divides by 4. Goes in 5 times. So if I take the square root of 4, that's 2. 2 square root of 5 is la respuesta. So that's C. Here's your answer. So 22 is 3 comma 2, and then 2 root 5 for the distance. All right. I'll go ahead and subtract that too. So since this is already getting to be kind of a long video, what I'm going to probably do is pick up the next part of this next week or later on this week, since this is getting to be kind of a long video. And I'll just split it into 2 parts. So I'll do the other 2 pages next time. And that would be lesson 1-4, 5, 6, 7, and 8. So I'll go ahead and just finish this page here. All right. So for GH, I'll go ahead and erase that too. GH is right here. So it looks like I need to go 4 spaces again. 1, 2, 3, 4. So half that much would be 2. And then I need to go down 2 spaces. So there's the midpoint right there. It would be 3 comma 0. 3 comma 0. Boom, boom. It's a lot easier when you have a graph. You can just kind of look at it instead of having to use the formula. So 23, 3 comma 0. And then I go 2 spaces and 4 spaces again. So I don't remember what the answer was to the last one, but it's the same exact triangle. It's a triangle with a side of 4 and a side of 2. 1, 2, 3, 4. Goes from 5 to 1. Yeah, it's exactly the same triangle. So you get exactly the same answer. I believe it was 2 root 5. 2 root 5 was the answer. And it's the same exact distance, same exact spaces to the left and down that you would go to the left and up to get from G to F, G to H, same. So it's the same distance. All right, so that one was pretty easy. And let's see, 24. So 24 is EH. Let's see, 1, 2, 3, 4. Hey, look, 4 spaces again. All right, so 4 spaces. And then I need to go up 1, 2, 3 spaces. Oh, no, I'm going to have to go 1.5 spaces up and 2 spaces over. 1, 2, 1.5. So right about there, if you can see that dot. So it looks like that's at -1, comma 0.5. Comma 0.5. And you could check it with the midpoint formula since you're getting a decimal answer. If you really wanted to, you would do -3 plus 1, and then take the average of that. -3 plus 1 is -2, and then divide by 2, get -1. Check. And then the y coordinates, you would add those up and divide by 2 as well. So you would have E is 2, H is -1. 2 plus -1 is the same thing as 2 minus 1, which is 1, divided by 2 is 0.5. So that's the answer for 24. And, oh, and then we also need to find the distance. So since it was 4 spaces and 3 spaces, actually this one's really nice because it's what's called a Pythagorean triple. 1, 2, 3, 4, and then we go up 1, 2, 3. If you go over 4 spaces and up 3 spaces, that's a Pythagorean triple, which means the hypotenuse is 5. Is a 3, 4, 5 triangle. Now, I can do the math for it if you want, but I would highly, highly recommend, especially if you're in Geo Honors, to remember this little Pythagorean triple. So c squared, that's 9 plus 16 is c squared. Scroll down a little bit here. 9 plus 16 is 25. And I bet you can't guess what the square root of that is. It's 5. So there you go. Yeah, definitely want to remember 3, 4, 5 triangle and be able to identify when a 3, 4, 5 right triangle is happening. That way you can just guess what the other side is. All right, so that was the answer to 24. Got 2 more, and then I'll end the video for today, and I'll pick up where I left off on the next one. But let's go ahead and finish up here. So 25, what are the coordinates of the point 2/5 of the way from H to E? Oh, very interesting. Okay, so here's what you have to do. Here's what you have to do. So we know, we already have the H to E stuff from 24, so I'm going to leave that up there, actually. We know what half of the way is, because we would take the average. And we know the distance is 5. And they say, okay, there's a point that's 2/5 of the way from H to E on the grid. So if you can imagine, here's my poorly drawn line. If I were to split this up into 5 segments, 1, 2, 3, oop, glitched again, 3, 4, 5. So there's my 5 segments. 1, 2, 3, 4, 5. All right. Not drawn that well, but, I'm trying. So if you were to split it up into 5 pieces, then you would have each of them be 1/5, right? So if I want to figure out what a point is that's 2/5 of the way from H to E, well, first of all, I need to know what distance that would be. That would be a distance of 2. It'd be a distance of 2, right? It's 2/5 of the way. So it's a distance of 2 away from H. And then the other thing is, I can figure out kind of where that would be. It would be roughly like over here somewhere along the path from H to E, right? So it's a distance of 2 away from H, which means if I do a little triangle here, so here's H, here's what I'm trying to find, and I'm trying to find the coordinates of this. So I need to find the coordinates. Well, I know H has coordinates, right? And then I also know that the distance, the hypotenuse there is 2, and then I also know that if I were to do the whole triangle, it would be a 3, 4, 5. So I have the whole triangle is a 3, 4, 5. So that's 4, that's 3. And now I have a triangle that's very similar, literally and figuratively, to that triangle. But it has a hypotenuse of 2. So if I divide 5 by 2, if I multiply 5 by 2/5, I get 2. So if I figure out what that is, 5 divided by 2 is 2.5. If I divide 5 by 2.5, I get 2. Or I can multiply by 2/5, which would be 0.4. So 5 times 0.4. If I want to figure out how the big triangle, the 3, 4, 5 triangle, is similar to this other triangle, I can just multiply by 0.4. I can multiply by 0.4. So if I want to figure out how far to the left and how far up I need to go, I can do the same thing here. 4 times 0.4. 4 times 4 is 16, so this would be 1.6. I would need to go left 1.6 spaces. And then if I want to figure out how far over here, I'd have to multiply that by 0.4 as well. 3 times 4 is 12, so this would be 1.2. Okay? So what I did was I just created a little mini triangle, and this little mini triangle is right here. It's that little triangle. That's this. And I just figured out how many spaces I would need to go left and up from H to get to that point now. All right, so this problem is a little bit weird, but basically how you solve it is you say, okay, I know the whole distance, and I know the whole distance makes a certain triangle, and I've already figured out what the distance is of the whole thing. And then I want a smaller piece of that distance, 2/5 of it, aka 0.4 of it, so I can multiply everything by 0.4, and that tells me how far I need to go left and up from a point that I know. Well, okay, so I know H is at, let me erase some of this stuff. I know H is at 1 comma negative 1. And then I need to go left by 1.6, which means I need to subtract 1.6. So 1.6. This would be negative 0.6. And then I need to go up by 1.2. So I need to add 1.2. Well, if I add 1.2 to negative 1, that's the same thing as 1.2 minus 1, which is 0.2. So I get this as my answer. Negative 0.6 comma 0.2 is where the location is that's 2/5 of the way from H to E on the grid. Right? And this is why this is one of the last questions in lesson 1-3, is because it's a little bit harder to figure it out. But there's your answer. Let's go ahead and do the last one. Last question. Here we go. So I'm going to erase all of this. And blah, 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 blah. Okay, this one is separate from the other ones. This one is separate from the other ones. So I'm just going to erase all of this here. Sadie models her neighborhood on a coordinate plane so that her school is at 8, 12. All right, so let's draw this out here. 8, 12 would be like over here somewhere. So S for school is at 8, 12. 812. And then the store is at 14, comma 3. So that'd be over here somewhere. Oh, school, store. There we go. 14, comma 3. All right. What are the coordinates of the point that's halfway between the school and the store? Okay, well, if we want the coordinates of the point that's halfway between, that just means we need midpoint formula, right? So the midpoint would be 8 plus 14. 8 plus 14 over 2. 8 plus 14 would be, let's see, oh, I just blanked for a second, 22. Heck in math. 22 over 2 is 11. So there's the x-coordinate of the point. And then we would need 12 and 3. 12 plus 3 over 2. 12 plus 3 is 15. 15 over 2 is 7.5. So the coordinates of the point that's halfway between would be 11, comma 7.5. That's it. A lot easier than 25, actually. So there you go. And by the way, for 25, there's other ways to do it. So if your teacher explains it differently, and that makes more sense than what I did to do number 25, then that's awesome. I take no offense. Whichever way makes the most sense to you is the way that you want to remember. So if somebody did that one and they have a little trick method or something, then awesome, go for it. But there's the answers for the first two pages, pages 64 and 65. This has been Mr. Kyle, Myers Mathematics. If you have not already grabbed my awesome free guide, it is on my website, myersmathematics.com. It's called The 5 Math Mistakes Everyone Makes and How to Avoid Them. It's basically a short little guide, little PDF guide, and it shows you what the 5 things are that I've narrowed it down to that people mess up on, ranging from a very specific example to just kind of more broad general stuff and just some general advice on what to do to understand math if you can't, figure out why you're missing the problem. Okay, so awesome little guide. Go check it out. It's for free on my website. And then also, of course, if you like this video, throw a like and then subscribe to see more videos like this. And I will see you again in another episode.